All right, we're back for example 2. Before we get started, we have to talk about this. So, factors that are shared by 2 or more whole numbers are called common factors. The greatest of these common factors is called the greatest common factor, or GCF, okay? So, let's talk about 12 and 32. And let's really talk about factors that are shared by 2 or more numbers are called common factors. Let's just talk about the factors of 12 first. So whenever I'm writing like all of the factors of 12, I always start with 1. All right, and I'm thinking to myself, okay, 1 times what is 12? And it's going to be 12. And I like to put them in order from least to greatest. So I know that 1 is going to be the smallest factor and 12 is going to be the biggest one, right? So after 1, I'm going to move to 2 and say, hey, is 12 divisible by 2? And it is, right, because it's even. And so I know 2 is a factor, and then I just ask myself, okay, 2 times what is 12? And that's 6, right? 2 times 6. So it's like each factor has a pair. So like 1 times 12 is 12. 2 times 6 is 12. So then after 2, I would think about 3. And is 12 divisible by 3? If I add 1 and 2 together, that's 3, and 3 is divisible by 3, so yes. And then it's going to be 3 times what is 12, and the answer would be 4. And then what you see here, so this is the kind of cool thing about factors, right? When you start with 1 and then you get to 12, right? So this 1 is the smallest and 12 is the biggest. And those numbers like are really far apart, right? But the next factor is 2, and its pair is 6. And see how the numbers are getting closer together? So here, 1 and 12, they're really spread apart. And then the numbers 2 and 6, they're a little bit closer, right? And then 3 and 4, I mean, they're practically, there's no other numbers. So when the numbers are really spread out, right, you keep looking, and then once you find the numbers that are really, really close together, then you know that you're done and you found all the factors. Okay? So those are all the factors of 12. 1, 2, 3, 4, 6, and 12. All right, let's think about 32. So we're going to start with 1, right? 1 times 32. Okay, and then let's think about the next one be 2, right? Is this divisible by 2? Well, it's even, so yeah. So the question is 2 times what is 32, and I'm pretty sure it's 16. Okay, then we're going to move to think about 3. Is 32 divisible by 3? If I go 3 plus 2, that's 5. Is 5 divisible by 3? No, it's not. Okay, so that means that 32 is not divisible by 3. What about 4? Yeah, 32 is divisible by 4. 4 times 8, right, is 32. And you see how the numbers are really far apart, right? And then they get a little bit closer, and then they're even closer. But they're not like right next to each other, like 3 and 4, right? There's still some numbers in between 4 and 8. So we have to see if any of those numbers that are between 4 and 8 are divisible, that are factors of 32. So the next one would be 5, right? And 5 is, 5 does not, this doesn't end in a 0 or 5. So 5 is not a factor of 32, or, 32 is not divisible by 5. Then we would look at 6, right? But for it to be divisible by 6, it has to be divisible by 2 and 3. It's divisible by 2, but it's not divisible by 3. So it's not going to be divisible by 6. And then we look at 7, but yeah, 32 is not divisible by 7. So that's it. These are all of the factors of 32. So 1 times 32, 2 times 16, and 4 times 8. And so do you see what they did? Like the numbers are far apart, they're getting closer, and then we checked all the numbers in between 4 and 8, and those weren't factors, so now we know that we're done. Okay? So these are all the factors of 12. These are all the factors of 32. Now what it says factors that are shared by 2 or more whole numbers are called common factors. Common factors. So let's see what the common factors are with 12 and 32. So what do I see? I see that they have a 1 in common, right? So that's going to be a common factor, 1. What else do they have in common? I see that they have a 2 in common, okay? So that's going to be a common factor as well. 12 has a 3, but 32 does not, so that's not common. They both have a 4, so that's a common factor, right? So 4, and then what, 6? This one doesn't have a 6. 12, this one doesn't have a 12, this one doesn't have an 8. So that's it. Those are all the common factors, okay? So factors that are shared by 2 or more whole numbers are called common factors. So these are the common factors, right? And then it says the greatest of these common factors is called the greatest common factor, or the GCF. GCF, okay, the greatest common factor. So out of all of these common factors, which one's the greatest? Which one's the biggest? Well, that is 4. So the greatest common factor of 12 and 32 is 4. Okay? All right, so let's look at example 2. So we have 2A and 2B, and it says find the greatest common factor of each pair of numbers. Oh gosh, 160. Holy goodness. Okay. All right, we got this, we got this. Okay, and there's actually 2 different ways, so we'll do this 2 different ways, okay? So sometimes one way is easier, sometimes the other way is needed, right? I guess let me show you the second way with this problem that we were just doing. Okay, so this is the first way. Okay, this is the first way. So I'll just say first way. Okay, that is the first way. Now the second way, and I hope I have enough room. Room. Let's see. We'll go back here. And we'll call this the second way. Okay, and I want to see both on your homework and on your notes. Okay, so what you do the second way is that you break 12 and 32 down into its prime factorization. So number 1, break numbers into prime factorization. Okay, so 12, right? So we have 12. We're going to break that in down. So 12 is the same thing as 3 times 4, right? 3, that's a prime number. Awesome. What about 4? 4 needs to be broken down to 2 times 2, right? So that basically means that 12 is the same thing as 2 squared times 3. Okay? Cool. Then we're going to move to 32, right? So we're going to break 32 down. So 32 is the same thing as 4 times 8, but this is a composite number, and that's a composite number. Neither of these are prime. So I'm going to break that down into 2 times 2, which is a prime number, right? And so we know that we're done there. I like to put circles around them to show that they're done. And then 8 is the same thing as 2 times 4, right? And then 2 is a prime number, so we're done with that one, but we still need to go with 4. 4 is composite. 4 is the same thing as 2 times 2, right? So now we have those, man, that's a lot of 2's. So what do we have? We have, this is the same thing as 2 times 2 times 2 times, so it's 1, 2, 3, 4, 5, 2 to the 5th power, right? Okay, so this is the prime factorization. Now, how you find the GCF is out of the prime factors, you see which ones are in common, okay? So I think I'm gonna write I'm going to write 12. 12 is the same thing as, right, 2 times 2 times 3, right? And 32 is the same thing as 2 times 2 times 2 times 2 times 2, right? So what do they have in common? They have this 2 in common, and they have this 2 in common. But that's it, right? That's all that they have in common. So that is the GCF, is 2 times 2, which is 4, which is what we came up with there. Okay? So GCF equals 2 times 2, which is equal to 4. Now, you can, when I did the prime factorization, I didn't write it out like that. But when you're looking at the prime factorization here with 2 squared times 3 and 2 to the 5th, you want to take what's common. So there's not a 3 over here, but there is a 2 squared here, and there's a 2 squared here, right? Because there's 2 squared. There's 2 squared and 2 to the 5th. 2 times 2 times 2 times 2 times 2 is 2 to the 5th, right? So there's a 2 squared here, and there's a 2 squared there. So that's how you know that the GCF is 2 squared, which is the same thing as 4. Okay? So those are a couple different ways to think about it. But those are the 2 ways, okay? So let's go ahead and we're gonna try both of those ways with these 2 numbers here. So we're gonna go with the first way first. Okay, and that's basically we have 100 here, and I think for this, for 100, I would rather do it this second way where I just break it down than have to list out all of the factors for 100, because that's going to take forever, but we are going to do it, okay? So the first thing for 100 would be 1 and 100, right? After that would be 2 and 2 times 50. We would go to 3. And I'm going to say that 1 plus 0 is 1, so 3 is not a factor. 4 is, though, and it would be 4 and 25, right? 4 times 25. And then I would go to 5, and yes, 5 is a factor, and it's 5 times 20. 6 is not going to be a factor because it has to be 2 and 3, and it has to be divisible by 2 and 3. And it's not divisible by 3, so it's not going to be divisible by 6. 7, no. 8, I don't think it's divisible by 8. Let me see. 8 goes into 10 one time. And no, it doesn't evenly go into 20, so it's not divisible by 8. 9, 1 plus 0 is 1, and that's not divisible by 9. What about 10? Well, yeah, 10 times 10, right? And there we are. We're at 10 times, you know, I'm not going to write, well, I'll write it, but 10 times 10. Like, look at it. The numbers are really far apart. They get a little closer, then they get a little closer, then they get a little closer, right? And then we're basically at just 10. So we know that we found all the factors. So these are all the factors of 100. 1, 2, 4, 5, 10, 20, 25, 50, 100. Okay? Now let's look at 60. Okay, so it's going to be 1 and 60, and then 2 and 2 times 30, and 3, yes, 3 times 20, and 4 times, pretty sure it's 15, 5 times, I think it's 12, 6 times 10, oh man, I'm running out of space, 7, no, it's not divisible by 7. 8, no, and 9, no. So these are all, man, that's a lot of factors. I think 60 has more factors than 100. That's crazy. Okay, so, but we're trying to find the GCF, right? So we have all the factors listed. Now we're going to find the common factors, which would be, you know, 1, 2, 4, 5, 10, 12, 20, 15, no, 25, 30, 50, 60, 100. That's it, okay? So those are all the common ones, and the greatest common factor would be 20. So that would be the GCF, okay? So the GCF is equal to 20, the greatest common factor. Okay, so that's the first way. Now let's go ahead and do this the second way. And I think for this problem, I'm probably gonna like it the second way better because I feel like I could probably figure out the answer quicker. So I'm gonna break down 100, right? And I'm just gonna go 10 times 10. I like to just have it, and then from 10, this is gonna be 2 times 5, right? That's prime, and then 10 is gonna be 2 times 5. That's prime, that's prime. So the prime factorization of this would be 2 squared and 5 squared. 2 squared times 5 squared, right? Okay, cool. Now, see that, I just feel like that's a lot faster than doing that. The other one would be 60. And I think I'm gonna go with something similar, like numbers that are close, like 6 times 10. Because then it just breaks down. Like if I go like, 2 times 30, I just feel like it takes forever to break down 30. So if I take numbers that are kind of close, then it's just easy because it's like, okay, 6 is the same thing as 2 times 3, right? Prime, prime. 10 is the same thing as 2 times 5, prime, prime. And there I have my prime factorization. 2 times 2, which is 2 squared. And then 3 and 5. Okay, so now that I have my prime factorization, I have to look for the common factor. So what do they have in common? They have this 2 squared in common, and they also have a 2 squared here. So I know that in my greatest common factor, 2 squared is going to be in that number, right? Because there's a 2 squared here and there's a 2 squared there. Here's a 3, but there's no 3 here. Here's a 5 squared, and this has a 5, so what they have in common is a 5. I can't say 5 squared. This has a 5 squared, but this doesn't have a 5 squared, so it's not in common. You just have to say what's in common. So what's in common is just a 5. There's a 5 here, and there's 1 5 there too. So that's a part of my greatest common factor. So basically, 2 squared is the same thing as 2 times 2, which is 4. 4 times 5 is 20. So my greatest common factor is 20. So when the numbers are kind of like smaller, I would say sometimes I like to do this first way, when the numbers are smaller. But when the numbers start to get big, like 160 or even bigger, like they can be bigger, that's when I like to do this second way of breaking it down, because it just takes forever. Like let's say you had like a number like 1,000 something. Like seriously, you know how long that would take to write all those factors out like that? So yeah. Okay, let's look here. 2B, finding the greatest common factor of these two numbers. So we're gonna do it the first way and then the second way again, okay? So first way, let's start with 26. I don't know if there's a lot of factors for 26. So obviously the first one would just be 1 and 26, right? Easy, easy. Then we go to 2, it's even, so we know it's divisible by 2. So 2 times 13. Then from there, we would move to 3, right? And 2 plus 6 is 8, and 8's not divisible by 3, so it's not divisible by 3. Then we would move to 4, and it's not divisible by 4. Then we go to 5, and it's not. And then we go to 6, and it's not divisible by 6. And then 7. It's not divisible by 7, and then we go to 8, and it's not divisible by 8, or 9, or 10, or 11, or 12. So this is it. These are all the factors. So I like to think through all of the factors. So, right, these are really far, and then these are closer, and then I think about all the factors in between there, and then I know that I have, once I've went through all the ones in between 2 and 13, and none of those are factors, then I know that I have all my factors. Okay, then I'm going to go to 52. So 52, right? The first one would be 1 and 52. The next one would be, it's even, so it's 2, right? 2 and what? 2 times maybe 26, because half of 50 would be 25, and then half of 2 is 1, so 25 plus 1 is 26. Okay, so 26, and then 3, is it divisible by 3? 5 plus 2 is 7. 7 isn't divisible by 3, so it's not going to be divisible by 3, or really any factor of 3, which would be multiple of 3, which would be 3, 6, 9, 12. None of those are going to be. Okay, so 3. What about 4? 52 divided by 4. I don't know. 52 divided by 4. 4 goes into 5 one time. 1 times 4 is 4. And then we drop it down. 4 goes into 12 3 times. Oh, it is. Okay, so 4 and 13. Okay, notice how the numbers are far apart and they're getting closer, right? They're not like touching, like, or the same number, like 10 times 10 is 100, or, you know, like 4 times 3, those numbers are really close. So we got to check all the numbers in between here still. So 5, right? No. 6, it's not divisible by 3, so it's not going to be divisible by 6 or 9. 7, no. 8, no. 9, no. 10, no. 11, no. 12. Yeah, so this is it, okay? So those are all the factors. Now we're trying to find the common factors, right? So the common factors would be 1, 2, and 13. Oh, and 26. Look at that. All right. And then the greatest common factor would just be 26, right? So the greatest common factor is 26. Okay. Now let's do the second way. Okay, so we're going to take 26 and break it down. I think just, 2 times 13? And look at that. 2 is prime, 13 is prime, so there it is, 2 times 13. That is the prime factorization. Then we're going to go, and see how fast that is? Let's go 52. I think I'm going to go with 4 times 13. And 13 is prime. But 4 can be broken down into 2 times 2. So prime, prime, prime. So 52 is the same thing as 2 squared times 13. Okay, so when we're finding the greatest common factor, we have to find what's common, right? So this has a 2, this has 1, 2, and this has 1, 2. So that means that our greatest common factor is going to have 1, 2 in it. And then does this have a 13? Yes. And they have a 13, so they both have a 13 in common. So my greatest common factor is going to have a 2, and it's going to have a 13. And if you go 2 times 13, you get 26, which is the same thing, right? So that's our greatest common factor. Perfect. Okay, now it is your turn, ladies and gentlemen. And I want you to check it out with this example and this example. And I want to see both ways, okay? So I want to see the first way where you write it all out and the second way where you do this, okay? For each of these problems. First way, second way, first way, second way, okay? You can do it. I believe in you. So here we go. Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out those problems, doing the first way and the second way. And when you get done, press play and we'll go over it together. All right, see you in a bit. Okay, let's see how you did. Okay, first way. First way, first way, first way. So, 12. What do we have? We have 1, 12, 2, 6, 3, 4. We're done, right? And then 16. 16 is 1, 16. 2, 8, 3, no, and then I think it's just going to be 4. Yeah, 4 times 4 is 16. So boom, that's it. Common factors, what do we have? We have 1, we got 2, we got 4, and that's it. So the greatest common factor would be 4. So if you got that with the first way, great job. Okay, let's do it the second way. New color. Second way. All right, so we're going to break down 12. I'm going to go 3 times 4, prime, not prime, 2 times 2. So this is 2 squared. The prime factorization is 2 squared times 3, right? Okay, now let's do 16. Break it down, break it down. We get 4 times 4. And you might have broken it down differently, and that's okay. But the prime factorization you have to have is 2 to the 1, 2, 3, 4th power. Okay, now we need the greatest common factor. Is what is common? Well, we have a 2 squared here, and we have a 2 squared within 2 to the 4th power. So we know that our greatest common factor is going to have a 2 squared in it. There's a 3 here, but there's not a 3 here, so we can't write it. So there it is. That's our greatest common factor. 2 squared, which is 4. Which is the same thing. So if you got both of those right, awesome, awesome. Okay, let's look at the next one. We're going to do the first way and the second way. So, first way, 15 is the same thing as 1 and 15 and 3 and 5. 25 is the same thing as 1 and 25, and pretty sure it's just 5. That's it. Okay, so common factors, we have 1 and we have 5. So greatest common factor is 5. GCF is equal to 5. Boom shakalaka, there you have it. Okay, time for the second way. Second way, okay, so we're going to take 15 and break it down, which is the same thing as 3 times 5, and that's really it. That's the prime factorization. Prime number, we're done. Okay, then 25 is the same thing as 5 times 5, and that's it too. 5 times 5 is 5 squared, right? So now we're going to do the greatest common factor, and so we have to see what they have in common. There's a 3 here, there's no 3 there, so I can't write that down. There's a 5 here, and there is 1 5 there, so I can write that, and that's it. Our greatest common factor is 5. So if you got both of those right, and you did the first way and the second way perfectly, you are amazing, and if not, go ahead and change your notes so they look exactly like mine. All right, that's it for example 2, and I'll see you in a little bit for example 3.